What up, mathletes? Whoop whoop. All right. It is 11.3, and our learning target is I will find measures of two-dimensional figures. I will find measures of two-dimensional figures. Okay, go ahead and take a minute. I'll zoom in on this. You should have your own paper copy. Work on the warm-up. Ready, set, go. Okay, I'm going to assume you pause this. Needed, what angles are supplementary to angle AEB? So we're talking about angle AEB. That's this angle right here. Well, we see it's definitely supplementary to angle AED. Those form a straight line. And it's also supplementary to BEC. Those form a straight line. Angle BEC. Perfect, and that's it. Name a pair of vertical angles. Well, vertical angles are diagonal from each other, so your answers could include angle AED and angle BEC, like we have up above, or you could even say angle AEB and angle DEC. So either one of those pairs would work. The measure of angle AED is 70 degrees. So AED, 70 degrees right here. What is the measure of angle CEB? So this angle, well, it's the same. They're vertical angles. So the measure of angle, what did they say? CEB, I said BEC, but it doesn't matter. CEB, same thing, is also 70 degrees. Okay, so we can label that. And what is the measure of angle CED? So that's this right here. Again, I said DEC, but CED is fine. If the measure of angle AED is 70 degrees, we already have that 70. Well, together these are a linear pair. That means we're going to do 180 minus 70, which equals 110 degrees. So the measure of angle CED equals 110 degrees because they're supplementary. If two angles are supplementary, are they sometimes, always, or never congruent? Well, they're not always congruent. We see that right now. We have two angles. This one's 110, that one's 70. They're supplementary, but they're not congruent. However, what if they both equaled 90 degrees? 90 plus 90 is 180. So that's the one case they would be the same. So we're going to put, if you can find even one case, you got to put sometimes. Always only works if it's every time. Never works if it's none of the time. Sometimes is at least once. All right, there you go. Pause if you need to. We're going to move on to vocab. Again, I'm going to get this centered in the screen. Pause this as needed. And, well, I mean, clearly you're going to need to pause if you're going to write it down. Write down all the vocab right here. We know a polygon is a closed plane figure with at least 3 straight sides, so at least a triangle. Perimeter is the sum of the lengths of the sides of the polygon, right? We add up all the edges. Area is the number of square units needed to cover a surface. Concave polygon is a polygon with one or more interior measures greater than 180 degrees. So something's concave might be like, hey, I have a square. It's a concave. It's going to bow out somewhere. Where convex means that it's straight or it can even curve in at times. All right, so a concave polygon is a polygon in which it can actually go inside like that, right? And then a convex polygon is usually our regular polygons. Okay? Those are kind of the difference there. So this is the concave, this is the convex, more regular, more the right size. All right, let's get rolling on with you'll see next on your paper, I gotta get rid of this. All right, next on your paper, you're going to see these shapes, and I'm just going to flip the triangle, and I want you to write down the formula for perimeter and area of a triangle, right? Which is b plus c plus d, adding up the sides. And the area is 1/2 the base times the vertical height. Okay? Square. We just add up all the sides. It's 4 times the sides because they're all the same. And the area of a square is s squared. It's the length of the side squared. All right, pause if you need to. I'm moving on. Again, I move on these pretty fast because I know you can pause it. The rectangular perimeter, we have length plus width plus length plus width, which is just 2 lengths plus 2 widths. And the area is length times width. A circle, instead of perimeter, we have circumference, which is either 2 times pi times the radius, and by the way, pi is approximately 3.14, or we have the area, which is pi r squared. Now, circumference, by the way, I did forget to mention this. If you have the diameter, which is the complete distance across, versus the radius, which is just half the diameter, the formula for circumference is just pi times diameter. So we have different options there. Awesome. All right. Let's move on to the back side. Again, I should probably leave this. Pause everything you need. I'm going to move on to the back side of our worksheet, our notes today. This is the real meat of the lesson. We got to go back and remember the distance formula. You remember that formula that said the distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. We're going to use that because we've got to find the distances between these points. I see I clearly have a rectangle right here, but I don't know what the length or the width is. So we're going to find that. So first I want to start out by finding the length. And what do we get for the length? Well, I'm going to do AD. I could do BC, it would come out the same. But I'm just going to do the length AD. And what does AD equal? It's the square root of my x's subtracted, so negative 4 minus 1 squared, plus my y's subtracted, 2 minus 7. Squared. And how I kind of work this out is I just say, all right, what is that really? Well, that's really just negative 5 squared right there, right? And that's just going to be, again, negative 5 squared. So this is going to equal the square root of 25, because negative 5 squared is 25, plus 25 again, which equals the square root of 50. And that is the length AD, so we know this is the square root 50. Now we need to find the width. As long as I have length and width, I can do all my different formulas. So my width is going to be AB. Again, you could find DC, it doesn't matter which, but I'm just doing AD and AB. And AB is equal to the square root of the difference of my x's, so negative 4 minus 0 squared, plus 2 minus negative 2. So 2 minus, and then what are we subtracting? A negative 2 squared, which is good because this becomes a plus. So I end up with what? Negative 4 squared, and over here I have 4 squared. So this is just going to equal the square root of 16 plus 16, which equals the square root of 32. So now I know my width is the square root of 32. And here's how I'm going to figure that out. Now it says to round, up here it says to round my answers to the nearest tenth. Notice I'm not rounding these at all. I'll round when I'm actually finding my values. That way we're only rounding once. So I know that for perimeter, it's equal to 2 times my length, which is the square root of 50, plus 2 times my width, which is the square root of 32. And that's going to be approximately, here's where you're going to want a calculator out. So I'm going to have 2 square root of 50, close off that bracket, and plus 2 square root of 32, close off that bracket. What does that equal? Approximately 25, let's see, I'd say 0.4, but that 5 makes it round up, so 25.5. So that's approximately 25.5, and we're going to start labeling it as units. Usually they give us the unit like inches, feet, anything like that, miles, but in this case they did, so we'll just say units. And what is the area? Well, the area is my length times my width, so that's going to be square root of 50 times square root of 32. So let's do that. Square root of 50 times, oh, I forgot to close off my bracket. So times the square root of 32. What does that equal? Well, that's a nice number, 40. That equals exactly, no rounding, 40 units squared, or square units. And that is how we use distance formula to find area. Now let's go ahead and repeat the process with this circle over here. Now, with the circle, we need either a radius or a diameter. In this case, we're given a radius right here. Okay, but again, I don't know that distance, so I'm going to find out what is the distance of CD. CD equals square root, again, of my x's, so 4 minus 6. 4 minus 6 squared, plus my y's, 8 minus 3 squared, which equals, well, first of all, what do I know? This is going to be negative 2 squared, and this is going to be 5 squared, right? So what does this equal? It equals the square root of 4 plus 25, which equals the square root of 29. So this is the square root of 29. That's all I need. Now I can find everything I need. So to find my circumference, it equals 2 times pi times the square root of 29. Let's put that in. If you have a calculator like mine, it has pi on it. If yours doesn't, use 3.14. So I'm going to have 2 times, I have an actual pi button, pi times square root of 29. That's about 33.8 units. That's approximately 33.8 units. Okay? And then let's find my area, which is pi times the square root of 29 squared. Now here's the thing, guys. A square undoes a square root, so that's really just 29 times pi, which is approximately 91.1 square units. Okay? Again, pause if you need to. Let's go ahead and take a look at the next examples.